Hello. In this video we're going to go ahead and talk about recursive process for geometric sequences. So far we have only worked with arithmetic sequences. Today we are going to work with geometric sequences, and we'll talk about those in a second. Our objective, please remember to write this down at the top of your notes, is that students will represent a geometric sequence with a recursive process. For prior knowledge, go ahead and do this on your own. At this point, you should be pretty solid with these concepts. But go ahead and pause the video, try this one on your own. Okay, so if I'm writing a recursive pattern, remember the first thing we need to do is identify our f of 0. So here, my d value, my common difference, we're adding 20 each time. So our d value is 20. Therefore, going backwards, our f of 0 value should be negative 15, right? I got 5 minus 20. So our recursive pattern for this problem is negative 15, f of x equals f of x minus 1 plus 20. For prior knowledge number 2, please go ahead and try this one on your own. Okay, if f of 0 is 20, then our d value is negative 9, located here. So 20 minus 9 is 11. 11 minus 9 is 2. 2 minus 9 is negative 7. And negative 7 take away 9 is a negative 16. Okay, today we're going to talk about a geometric sequence. And a geometric sequence is a sequence where the ratio between two consecutive terms is constant. This ratio is called the common ratio, and we're going to represent this with the letter R, and I'll show you that in a second. Please remember to get this in your notes. Some examples of a geometric sequence are 6, 12, 24, 48, 96. And we can go ahead and represent this in a table, right, where our first term is 6, our second term is 12, third term is 24, and our fourth term is 48. Another example would be 4, 12, 36, 108. Okay, and here again I have a table representing these values. So what is a geometric sequence? Well, a geometric sequence is a sequence where the ratio between the two consecutive terms is constant. Now I hope you noticed, well, to get from 6 to 12, here all we did was we multiplied by 2. 12 to 24, again we multiplied by 2. And 24 to 48, we multiplied by 2. Here, 4 to 12, we're multiplying by 3, and this pattern continues. So a geometric sequence, right, is where we are multiplying. Additionally, this occurs when we divide. So a geometric sequence still, if we went 96 to 48, 48 to 24, 24 to 12, that would also be a geometric sequence. Now, how you find R is you take one term, you take f of x, and you divide it by the previous term, f of x minus 1. So here, for example, I would have 12, and I divide by 6. Well, 12 divided by 6 is 2. So that's all the R value, the ratio. Going over the recursive process, remember, in order to create a recursive process, you have to identify your initial value. F of 0 equals the initial value. And then we, secondly, identify how the outputs are changing. And for geometric sequences, we identify our common ratio, where here R is our common ratio. So notice that this is not indicated on your notes. Please put where R equals this. Yeah, please add this into your notes next to the recursive process skill box. Add this in, and right here, please put R equals the common ratio. The common ratio. Okay, so let's go ahead and take a look at some examples. So for our first example here, we have 10, 20, 40. So from 10 to 20, we multiplied by 2. Does this pattern continue? 20 to 40? Again, yes, we multiplied by 2. So that means R is equal to 20, and they want us to write a recursive process. So remember a recursive process, we need our initial value. That is step 1 that we have. So in order to find f of 0 here, we're going to have to go backwards. So instead of multiplication, what is the inverse of multiplication? That is division. So we're going to divide by 2. 10 divided by 2, that would be 5. So f of 0 is equal to 5. Actually, I'm going to undo that just to show you what's plugged in, right? So recursive process always says f of 0. And then our second line, f of x equals, well, it's always the previous term, f of x minus 1. And then we add in our r value. Notice it's r times f of x minus 1. So here it is going to be, oh, notice I said r20. That's incorrect. It's 2. Sorry about that. And we multiply by 2. So 2 times the previous term gives us the next term. The second example, notice how I said we may be multiplying or dividing. Here we are dividing. Now when you divide by a value such as 2, when you divide by 2, you are really multiplying. You're multiplying by 1 over that value. So if you divide by 3, you're really multiplying by 1/3. You're taking 1/3 of that value. So here's what we're going to do. Whenever you divide, go ahead and put r is equal to 1 over that value. So here our ratio is 1/2. What's 1/2 of 100? 50. What's 1/2 of 50? 25. Okay? So I have my r value, and now I need to go ahead and find my f of 0 value. So when I do this, the opposite of division is multiplication. So 100 times 2 would be 200. That is my f of 0. So here's my recursive process. F of 0 is equal to my f of 0, which is 200. And the second line, remember these always have 2 lines, f of 0 equals and f of x equals. Well, the previous term, f of x minus 1, right? That's always a constant. That's why I wrote it in black. And then we're going to multiply times our ratio. And here our ratio is 1/2. So 1/2 of the previous term gives you the next term. And that is our recursive process for a geometric sequence. Remember, that's our objective. Our objective is to get this down pat. Can you guys go ahead, pause the video? I want you to try this problem on your own. Okay, so hopefully you've done this problem by now. Please check your work against mine. 6 to 18, well there we multiplied by 3. 18 to 54, we're multiplying by 3. So since we're multiplying, this is indeed, in fact, geometric. So our value is, I was about to write 18. Nope, it is 3. R is 3. And I need to find f of 0. So f of 0, I'm going to go backwards, and instead of multiplying, we divide by 3 to get the previous term. You do the inverse operation. So 6 divided by 3, that is 2. So therefore, f of 0 is equal to 2. And now we construct our recursive process. So f of 0 equals f of x is equal to f of x minus 1. And all I'm going to go ahead and do, is complete this. So f of 0, that is 2. F of x is equal to 3. And that is your geometric sequence. For these next examples, they're just like what we did yesterday. Go ahead and please write this down. You're going to start with your f of 0 value, that's -1. And here in the recursive process, they tell you that your r is 3. So -1 times 3 is -3. -3 times 3 is -9. -9 times 3 is -27. And -27 times 3, oh dang, I'm going to whip out my calculator for that one. I don't have that one on deck. 81. I should know that. Okay, so that is this example. That's how you construct the first 4 terms. Example 5. Here again we're given f of 0 is 64, and I need the next 4 terms. So I'm going to take my r value, which is 1/2. Well, 1/2 of 64 is 32. 1/2 is 32 is 16. 1/2 of 16 is 8, and 1/2 of 8 is 4. Those are those examples there. Can you please go ahead and try this example on your own? Okay, so hopefully you have tried this example. F of 0 is 2, and I have 4 as my R value. So 2 times 4, well, that is 8. 8 times 4, well, that is 32. 32 times 4, well, 4 times 2 is 8, and 4 times 30 is 120, so 128. And then 128 times 4, again, I don't have that one ready, and I should know this, but 4 times 1, 2, 8 gives us 512. Okay. Remember, our objective for the day was to go ahead and represent a geometric sequence with a recursive process, and we have done that here. For closure, I'm going to skip past the relevance. For the closure, what is the difference between arithmetic and geometric sequence? Well, in arithmetic sequences, we add and subtract. Geometric sequences, we multiply and divide. Don't forget to like my video, subscribe. Schwartz of the Berg, out.